We learned what friction is. We learned how friction is a force that acts between rough surfaces, and how friction starts to act when an object is moving or is trying to move. This is what we learned last time, and we saw how the size of friction can change according to the force that you apply in trying to move something, and how it reaches a maximum value, after which it will stay in that value when the object starts to move. We call it the maximum friction. And that moment when the object is about to move, it is said to be in limiting equilibrium. It is not yet moving, but it is about to move. So that's the last moment that it is going to be in equilibrium. So it's called limiting equilibrium. At that moment, there is maximum friction acting on it. And you can find this F max using the formula mu r. We did one question from the book, and I think I left the last part of that question for you to, good afternoon, Nathan, for you to do on your own. Did you calculate that distance that that the particle travels up the plane? That part 2 of that question was just application of, sorry, I'm burping, so I just had my lunch. That's just the use of equations of motion. From what I remember, I didn't do that part 2, but I left it for you to do. Did you do it? While you check that, or any other homework that I gave you, I don't think I gave you any homework. We have to do a couple of more questions until you properly grasp how to deal with questions involving friction. So for you to get to that standard, we all have to get together and do a couple of questions together, not all by yourself. So until that, I will not assign you questions from friction. Can you check to see whether you have done part 2 of that? This is in my book, question number 15, in end of chapter review exercise. Have you completed it? There was a part 2 in it. Let me check who's here until you. Okay, so Madara is here. Good to have you, Madara. Looks like everybody's here. Oh, again, I'm getting a message saying my internet connection is unstable. Why is that? Please let me know if there is any issue with the visual or the voice, okay? Okay, so you're not telling me that question, the last question we did, if I show you.
Miss, you are muted.
Give me a moment, I just changed the router. Okay, let's see whether this will work now. Okay. Give me a moment, I'm checking. Okay, it's working. Is there an improvement? I changed the router to a different one. Yes, no, okay. Right, the recording is continuing. I will show you the question that we did last time. This was what we did. You remember? Can you check in your books? Question 15. And then we did like that. We found F max. It was part 1 was a show question. We had to show that the acceleration was -6, and we got that. Okay. Make a note of how we have applied F equals ma. Very, very important. F equals ma is a vector equation. You have to say in what direction you are applying it. And also you have to say to what object you are applying it. Here we didn't specify that because we only have one object anyway. But if there can be questions where you have 2 or 3 particles, then you have to say to which particle you are applying it. These little things are very important. So here it's just one object, so I just need to say in what direction I apply it. So I've done that here, and we got -6. And then part 2 was this. Okay, part 2 was this. The question is, given that the particle's initial speed is, there you go, initial speed is 5.4, so u is 5.4. We found A. It says find the distance that the particle travels up the plane. So we want to find S. So it decelerates and finally stops. Until it stops, how far it travels. So v is 0. We want to find S. So it's the simple application of v squared, one of the equations of motion. Do you have the answer to this? You need to speak. Who has the answer to this? So no one has done it. No one did it, huh? I'm not going to do it. This is just like too simple, right? So let's look at the next question. So as I said, we will all do a couple of questions together. So I will show you how to do them. That's how you learn, okay? So after about 5 questions, oops, there is a breeze here. I might have to close the window. If I have to, I will do it. Let it be for now. Okay. I'm going to show you a little like a question on like a tutorial that I used to give you. I can't give you now. So I will show you the questions like this. I will take a picture of this and send you. There are, okay, thank you, Tarindu. So Tarindu says 2.43. Very good. 2.43 meters. So this particle decelerates up the slope for 2.43 meters and then stops and will come back. So we are not worrying about the motion afterwards. Okay, so let's do some questions on friction. Here's your first one. You can just write exercise. Okay, this first question is May 2019, version 1, paper 4.1, taken from paper 4.1, version 1 paper. You might want to write the question. Can you quickly write it? Or I'll, no, you can't. Can you quickly write it?
Miss, can you give us 5 minutes?
Okay. 5 minutes to copy this, Malit? 5 minutes?
With least casualties.
300 seconds?
Okay, let's lower the bar.
3 minutes, go, quick.
Okay.
I can read if that will help you. So I'll read it slowly. A particle of mass 1.3 kg rests on a rough plane inclined at an angle theta. It's like that, inclined at an angle theta to the horizontal. So this angle is given theta, where tan theta is 12 upon 5, where tan theta is 12 upon 5. The mu, let's shorten things. It says the coefficient of friction. So let's write the mu between the particle and the plane is mu. Oh, that doesn't make sense. You have to say the coefficient of friction between the particle and the plane is mu. So they have given it so they have given it, not the value, but it's given as mu, okay? The coefficient of friction between the particle and the plane is mu. Part 1. A force of magnitude 20 newtons, a force of magnitude 20 newtons I'm going to shorten it. I'm going to say a force of magnitude 20 newtons no, you have to write all that. Parallel to the line of greatest slope of the plane, parallel to the line of greatest slope of the plane, a force of magnitude 20 newtons, parallel to a line of greatest slope of the plane is applied to the particle, is applied to the particle, is applied to the particle and the particle is on the point of moving. The particle is on the point of moving. If you can underline that little bit, please. On the point of moving, it means it's about to move. It means it's in limiting equilibrium. That's another way of saying it, okay? And the particle is on the point of moving up the plane. Show that mu is 1.6. Show that mu is 1.6. 4 marks for that. Then the force of magnitude 20 Newton is now removed. The force of magnitude 20 newtons is now removed. Part 2. Don't copy part 3. It's from work and energy. We can't do it anyway. So you can drop that. Part 2. Find the acceleration of the particle. Find the acceleration of the particle.
Miss, how long did that take?
How long would what take?
Right now, from the moment you said go.
From how long did it take to read this?
Yeah.
I don't know. How long it took me to read it?
Yes.
Yeah.
News for us.
How long did I take?
Yeah.
Okay, Mihil, that's okay. Mihil is not late. It's fine, Mihil. We are just copying this first question. It's on friction. Okay, so let's begin. Okay, is the document bright enough? Okay, that should be okay.
Yeah.
Yes, miss. It's bad enough.
I'm going to remove the question now. So you have the question. Let us all draw a sketch of what they are talking about here. Can you start the sketch while I remove all this? Can you start the sketch? Let's see whether we are able to do the sketch properly. So that's a vital part of.
Miss, can you show the question for a second?
For a
2
second.
seconds.
Second na? Second. Ting, second, gone.
Miss, 3.
1, 2, 3.
Okay.
Enough.
Only question 1, right?
Only question 1. You can take a screenshot.
Okay, miss.
Yeah, okay. I will send you this anyway, okay? Right. Draw a sketch. So, you're all drawing together. This is just a sketch. is given 12/5. So you will always write these little information given on the side. Coefficient of friction given as mu. So I'm making a note of that. Mu is given. It's given to you. It's mu. Mass is given. That I will mark on the diagram. I'm going to mark the forces acting on this. Weight. Notice how I draw a long line for the weight arrow. Okay. I know the mass is 1.3, so weight would be 13 newtons. So I will put 13 here. Mass into G. G we consider to be 10. So 1.3 is the mass, into 10 is 13. So the weight is 13. Then you can mark the reaction force. Oops, sorry. And I will extend that line like that. That's the perpendicular line to the slope. There's your reaction.
Miss, it's also known as normal reaction, right?
It is the normal reaction, yes.
Okay.
Sorry that my line was not very straight. It should be like that. Okay. Then I have to mark this force of magnitude 20 that is applied parallel to the line of greatest slope. I would like it at this point, if one of you can, excuse me, can show me if you have drawn it already. How do you draw that force? Is anyone able to switch on the camera and show me how you have marked it? This 20 newtons externally applied force is acting parallel to a line of greatest slope. How is it acting? Who can show me?
Which it acts along the inclined plane.
That's right. Upwards. Okay, upwards.
Upwards, yes.
So you can mark it here. Like that. Okay, make sure that you got that right. I know that sometimes you might, now let me draw this in pencil. If you draw it like that, okay, I encourage you to always have your force arrows start on the object and point away. It's easy to work with them then. Okay, so this force, if you draw that to 20 newtons force like that, that is correct too. But I have placed it here. Do you see how it's more? It's easier to. It's easier when you think of. When you want to combine the forces, it's easier if you draw your force arrows pointing away from your object. Pushers and pulls, all forces can be drawn like that. Now, if they had said that you are pushing the object up, it could be drawn as that. A push from down could be thought of as a pull from somebody's pulling from up. Same thing, right? So I prefer to draw it like that. So how much is that? 20. One more force I have to draw. Which one is that?
The frictional
Friction.
force.
Friction. It's about to move up. So it's not moving, but it's about to move up. Yes, Hatfi. So friction would be acting.
So which is maximum?
Down the slope.
Miss,
And
that would mean it's about to move, right?
It's not moving. I will mark it as F max. Simple F max. I have now marked all the forces acting on this particle. There are 4 forces acting. 4 forces acting. Okay. And you know that we always, it's convenient to split forces that are acting at angles into horizontal and vertical components. Now, when I say vertical and horizontal, my new vertical and horizontal are with respect to the slope, this way. Okay, so let me just show you here. This is my horizontal, this is my vertical, this is my vertical. When you are on a slope, your vertical is the vertical to the slope.
Miss, isn't that 1.3?
Which one?
The weight.
Mass is 1.3, so
Yeah,
weight
yeah.
is 1.3 times 10, that is 13. Clear?
Yes.
Okay. Ah, so, oh, I'm sorry. So this, I did not even talk about this. W equals mg, because this is something you learn in your O levels. Weight is equal to mass times gravitational, not gravity, gravitational acceleration. G here is gravitational acceleration. Gravitational acceleration. There is another name for it, or you can call it gravitational field strength. Same thing. And its value is 10 meters per second squared. G is approximately 10. So weight of an object is mass times 10. Okay. W equals mg. I took it for granted. I mean, I thought you like know it. Okay. Now we know it is in limiting equilibrium. Let me write limiting equilibrium. It's in limiting equilibrium. Now, what am I supposed to find? I want to find what mu is. Whatever it is that I want to find, the only thing I can apply here is, now the particle is in equilibrium. The only thing I can do, this is the beauty of these questions. I don't have like 100 options to choose from. I have only one thing to do anyway. What is that? If the system is in equilibrium, my system is just a particle, my particle is in equilibrium, I can consider vertical equilibrium and horizontal equilibrium. Vertical equilibrium means I equate upward forces to downward forces. Horizontal equilibrium means I equate rightward forces to leftward forces. I get two equations. Whatever I want to find can be found using those two equations. That's it. Okay, so here it happens to be mu that we are finding. It could have been something else. Whatever it is that we are finding, what we have to apply is that if your object is in equilibrium, you simply apply conditions for equilibrium. Now this is in limiting equilibrium, so I'm going to consider vertical equilibrium and then horizontal equilibrium. Okay, let's start with vertical equilibrium. So vertical equilibrium this way. Remember, that's my new vertical equilibrium. When I consider vertical equilibrium, I look at my diagram, I can see that R must equal the vertical component of weight. Let me split weight into the two components. I can split weight into this and another one this way. Okay. Oh, did it go out of focus? Sorry. Right.
Okay, now it's back.
So these two black arrows that I included into the diagram, those two can replace 13. You can forget the 13 now. Throw it away. This is no more there. Throw the 13 away. I replaced it with its two components. What are they? This is 13. This is 13. This angle here is theta. Okay. I hope you can see the importance of having the arrows starting from the same point now. These resolving into components becomes very easy. The diagram becomes very clear when you have all the arrows lines going from one point. The angles become very clear. So 13 cos theta. Where's my, this black is not good. Do you see a black pen? No, no. You have one. It's windy, no? Thank you. 13 cos theta, and this is 13. This other the horizontal one is 13 sine theta. And now you can see that you're going to be needing cos theta and sine theta on the side here. This is why they have given you tan theta. If you know tan theta, you can work out any trigonometric ratio of theta that you want. If I do it now, before I continue this vertical equilibrium, realizing that I'm going to be needing sine theta and cos theta, I go back up here and in a little bubble, let me go into a little bubble, and I'm going to work out in a little bubble, I'm going to work out, you can do these little bubbles in the exam paper as well, okay? I am given tan theta, so I can put that information into a right angle triangle. If this is theta, this is 12, and this is 5. That's what they have given me. Opposite is 12, adjacent is 5. Then my hypotenuse would be 13. It's a Pythagorean triplet. 12, 13, 5. I hope you know it. If you don't know it, use the calculator. You will find the length of the hypotenuse to be 13. Then cos theta is 5 over 13, and sine theta is 12 over 13, correct? See, okay? You find that information that you're going to need in these equations on the side. It's extra work. It's additional little work, okay? So have it in a little bubble. That makes your work clear. So the tan theta was given for you to find those. Now, let me come back to vertical equilibrium. R is equal to the vertical component of weight, that is 13 cos theta. I will first write 13 cos theta, and then in the next line, I would apply cos theta. 13 times cos theta is 5 over 13. This gives me what R is. R is normal reaction force is 5. Sorry. Normal reaction force is 5. Now, they didn't ask me to find that, but I'm doing it anyway, because I'm going to need that to find what they want me to find, which is mu. I'm not even looking at the question. I'm just doing what I'm supposed to do here. I know it is in equilibrium, then I apply the equations for vertical equilibrium and horizontal equilibrium. Okay, Hatfi is asking. Yes, Hatfi is asking, please, when you ask a question, put it for everyone, then everyone, because it applies to everyone, everyone can learn from it. Hatfi is asking whether, can't we find theta from this? Theta is tan inverse of 12 over 5. Yes, you can do that too, but you will see that then what you get is a irrational number. Find find the angle theta. You don't get an exact answer. Remember, they will always give you nice numbers here that cancels out. Yes, you get 67.38 ... If you don't take the whole answer to calculate cos theta, you won't get nice, you won't get these numbers simplifying that way. This is exact. I'm working with the exact numbers. Okay. Good, Hatfi. So you can do it. Why we avoid doing that is because theta is going to be an irrational number angle. The angle is an irrational number, and it's difficult to work with it. When you then use that angle to compute cos theta, you have to put the whole theta there. If not, it would be wrong. If not, you would be approximating. It will not be exact. So as you see here, they give you numbers to cancel nicely. Okay, right? We found R. I mean, not that we did it to find R. We just found R. Fine. Then I'm going to consider horizontal equilibrium. Horizontal equilibrium, right? So upward, I mean rightward and downward, not downward, leftward, right and left. Look at your diagram again. Only one force to the right, that is 20. So 20 is equal to, okay, come back to the diagram. I have two forces acting to the left, that is F max and 13 sine theta. F max and 13 sine theta. So I can say 20 is equal to F max plus 13 sine theta. F max plus 13 sine theta. Now this is where I'm going to get mu in it. I know F max can be written as mu r. Okay, so in the next line, let me write F max as mu r. Mu r. F max is mu r plus, and then I can put r from here. I will do that in the next step. Plus 13 sine theta, I have found there 12 over 13. 13 gets cancelled. 20 is equal to r. I have here r. I will substitute that here. So that's 5 mu plus 12. See what a simple equation this is? And I mean, you can't help it but finding mu from this. Even if you had not read the question, you could have just started to apply equations and found what you can find, right? So can you find mu from this little simple equation? Mu is what? Mu is how much?
8 divided by 5, which is basically 1.6.
Right, 8 divided by 5, which is 1.6. They said, show that mu is 1.6, and we are done. We showed that. Is this clear? These are very, now I like mechanics problems because they are, I mean, I don't know how to say it. It's like,
They are based on day-to-day things.
that too, that it's close to, oh, Nathan says they're fun to solve. And I mean, did you see, like, when they said that it was in a limiting equilibrium, these were not their exact words. They said it's about to, what did they say? They say the particle is on the point of moving up. That was the phrase that held the key thing that we are, that tells us what we are supposed to do. Limiting equilibrium. You see that word, then you know what you have to do. It directs you in this path. Limiting equilibrium. Then I will consider vertical equilibrium and horizontal equilibrium. And that will, by applying that, you will be able to find whatever they're asking. That is it. So it's very, Nathan adds at times. They are fun to solve at times. No, I would say they are fun to solve always. Okay, let's go to part 2 of that. So this was part 1. Let me write part 1 here. Okay, part 2. Part 2, if you remember, or if you have your question, says the force 20 is now removed. I will show you it again. The force 20 is now removed. Find the acceleration of the particle. Now 20 newtons is now removed. We have to redraw our diagram because now it's a different scenario. Forces got different. Now they are different. For example, your normal reaction would be different now. It's not the same case now. So you have to treat it like a new problem now. So you redraw it without the 20 newtons force. Let's quickly redraw. Sketch again without the 20 newtons force. Let's draw. Theta. Here's my particle. There's my 13. Here's my R. There's my R. This is rough. The slope is rough. Now you have to think there are no external forces applied on this object trying to move it up or trying to push it down. It's just left on the slope and there is friction. If you keep something on a slope, it will naturally be trying to move down. Which force is trying to move it down? The horizontal component of the weight is trying to pull it down. And then friction would be acting here too. But in what direction? Because now the particle is trying to slide down. It's not moving, but it will, yes, to the right or up the slope, up the slope. There will be friction up the slope. Oh, they are saying, I'm sorry, they are saying it's accelerated. Find the acceleration of the particle. So they say that it is accelerating. So it starts to move down. So show with an arrow outside of the particle with double arrows and write A to say that it's accelerating downwards. Then it is very clear. Friction would be acting up the slope. And would it be maximum friction or something lower than that? Can we mark it as F max?
No,
Nathan says
or
no.
maybe.
There
I
is no
don't know.
maybe. It's yes or no. Once you have started
Yes.
moving, please go back and refer the note. Or that means if you have not understood friction properly, then once it starts to move, that means friction has
It's still
increased
F
up to the
max.
maximum. And now it will stay.
Ah, okay, okay.
It is F max. If your object is moving, your friction is F max. At the limiting equilibrium, and also when it is moving, it's F max. So there are only three forces now, three forces. Okay. But at the same time, I'm going to do my resolving of my forces. Let me resolve the 13, make it a habit to do this always. I'm going to resolve the weight. And I mean, now I know the two components, right? Did I find it? Yeah. 13 cos theta, 13 cos theta was 5. So this will be 5. And this will be how much? So I'm replacing, okay? You can erase the 13 off here. Actually, this diagram can be misleading. All these three are not there at the same time. The moment I add these two black arrows, the 13 arrow has to go. Okay, I'm replacing it with these two black arrows. Right, what is 13? We found it earlier, 13 sine theta right here. 13 sine theta was the horizontal component. That gives me 12. Okay, so I'm going to just write 12. I hope that is clear. I'm using my previous work. So 12 and 5. And now, I mean, I can even remove this. Okay. Now, in contrast to what was happening in part 1, in part 1, the particle was in equilibrium. If your object is in equilibrium, you apply conditions for equilibrium. But if your particle is accelerating, then again, you are, oh, Malik has already found. You are like confined to doing just one thing. If your particle is accelerating, the only thing you can do is apply F equals ma, second law. Okay, so let us apply that. Whatever they're asking us to find, it must come out of F equals ma. So and remember, you apply F equals ma in the direction of the motion. So down the slope, F equals ma. Okay, F equals ma. So this way, F. Now, for that, I don't need the vertical forces. They are balanced. This is still in vertical equilibrium. This way it is moving. And it is moving down means 12 is greater. So the resultant, capital F, remember in F equals ma, is the resultant force in this direction that you are applying your equation. So in this direction, resultant force is 12 minus F max. 12 minus F max equals mass is 1.3 times A, 1.3 A. Now, I need F max here. Is it the same F max as before? Nope. You have to find F max for this scenario now. F max is mu r because r is now different. I think it's not different for this particular example, because the earlier external force that you applied had nothing to do with r. It was perpendicular to r, so it didn't affect r. So F max actually, if I write 12 minus F max is mu r equals 1.3a. 12 minus mu I found 1.6. And what is r? In a little bubble here, if I do vertical equilibrium, I have already done it before, but it's better to do it here again. R is equal to 5. Consider vertical equilibrium. R, upward force R, is equal to the downward force 5. Okay, so 1.6 times 5 equals to 1.3a. You solve this to find a and tell me what you get for a.
Zero 0.307. 0.308.
Or is it 3.08?
Hmm?
Is it 3.08?
Yes, miss.
3.0.
3.08 meters per second squared. 3.08. See whether you all get that. Girls, you have to talk to me. You have to communicate with me in some way. It's always the same. Malit, Nathan, Hatfi, and Tarindu, and Mihil also. So you all somehow communicate with me. You let me know if you you have some form of communication. The girls aren't saying anything. It's very difficult. Then I don't know whether you are. Okay, Rachel, it's clear, na? Joanne, Kavindi, Bimandi. Where's Bimandi? Oh, Bimandi is not here. Clear, na? Okay. I mean, make sure it is 100% clear. Okay, Joanne. Did Bimandi say yesterday that he Sasindo? Maybe it's still night time for him. I don't know. So I will have, yeah, I will be sending this to him. Did Bimandi say that she can't come today? I can't remember. Okay, anyway, right? Let's look at the next question. Here's your next question. Quickly copy this, please. Number 2. Oops, sorry. Wait, I will zoom this up a bit. What is this?
Miss, can you read it first so that it's easier to write?
Okay. Can you see number 2, this one?
No, miss, we can't see the other corner.
You can't see what?
We can see the left.
The
but,
right-hand
the
corner.
right. Okay. No,
Okay,
stop.
now good.
Sorry. Wait, let me, because I have my chat box open there, so I didn't see that you, okay. If I read, no, I will not read. I think it will be difficult. No, I think it's easier for you to just look at this and copy. So I will let you copy. Let me know when you are done. Done. Okay, Malik says yes. Can I remove the question? Okay. Did you get scared? Right. Sketch. Let's draw a sketch for what they're saying here. The particle is projected. A particle is projected from a point A with initial speed u up a line of greatest slope PQR of a rough inclined plane. The distance, all that. So shall we draw? Okay. Number two. Question number two. Again, you have an uh, inclined plane. They're talking about 3 points on the plane, PQR. So let me use the ruler this time. Okay, we draw a big diagram. Angle of inclination of the slope is given. Have they given? Not given. The particle projected from a point P. It's projected from a point P. So let me mark it somewhere here. Let that be P. Okay, point P. With initial speed. So let this be my particle. Okay. You project it from with a speed of u up a line of greatest slope PQR of rough. The distance PQ and QR both are okay. So you have Q somewhere here, and then R somewhere here. They are same distance, both 0.8, 0.8. The particle takes 0.6 seconds to travel from P to Q and 1 second from Q to R. Looks like this question will involve equations of motion. They are giving a lot of motion related information, the initial speed, the time taken, the distance and all that. So that's a nice twist to our forces. This is essentially a force question related to, this is from forces in forces and motion question. So since our particle is moving, they can easily incorporate something related to, they can bring in and ask you to find certain things about the motion and get you to apply equations of motion. It's fine. It's nice then. Okay. So note that they are talking about this P to Q and Q to R separately. So if you are taking the information down, like the information for equations of motion, U, V, S, T, A, and all for those information, you have to do it for P to Q separately and Q to R separately. Okay, I think. Is it the same acceleration? It's this, yeah, I mean, it's the same, it's decelerating, right? You're projecting it from P and then it will decelerate, right? Part 1 showed that the deceleration of particle is 2/3 and hence find U, giving your answer as an exact fraction. Okay, if I write the information from, so what do you think? I'm going to write from P to Q. If I write from P to Q, I hope you remember that whenever you want to apply equations of motion, you have to say to what section of the motion you are applying your equations of motion. So right now, I'm not very sure whether I would have to consider the whole P to R motion or Q to R or P to Q. I have many options here, but I'm going to write the information from P to Q first. So if I just consider P to Q section, U is U, S is 0.8, T is 0.6. I can find A right from there, isn't it? I can find A from that. Remember, if you have 3 information, there are 5 things that are related in equations of motion. Out of these 5, if you have 3, any 3, you can find everything else, other 2. So from P to R, it's 1 motion, 1 acceleration. By considering P to Q motion, we can find A. What's the equation? S equals ut plus half at squared, isn't it? Can you apply this and see whether you get A equals minus 2/3? You have to get a minus answer because it's deceleration. And I'm applying it in that direction, right? So that way I'm taking as positive. Let's see, 0.8.
Miss?
Yeah.
The question says that the time taken to travel to move from Q to R is 0.6, right?
No, Q to R is 1 second.
Q to R is 1 second.
Yeah.
So Miss, can you please show the question one more time?
Hold on, there's a delay. All right.
Okay, Miss.
Okay. And
thank you. Yeah.
just now I realized another thing. U is given as U. So we have to, you can't find acceleration from just from this, because we have to find U as well. That is why they have given another set of information from Q to R. We will have to use that too. Okay. So because here my U is U, it's not a number. So 0.6 U plus A over 2 0.6 square. Now I have U in this. I need to find that. Oh, I need another equation relating U. What I can do is, any suggestions? I can apply all the way from P to R. Along with this, let me consider from P to R. Now you tell me why I did not take from Q to R. If I consider Q to R, I don't have enough information. Q to R, I only have the distance and time. I don't have 3 information. But if I consider from P to R, again, I know the initial speed is U. SC is the total distance. That will be 1.6. Time is 1.1. Time is also 1.6. And I can write again another equation, S equals ut plus half at squared for the motion from P to R. Is this clear? Hatvi is asking. Yes, Hatvi here. Right? So since we don't know U, that is why we need to look at applying an equation to another section. Okay. Is it clear why I picked P to R? Please think about it. I have altogether 3 options when you are thinking of applying equations of motion. They are talking about the motion from P to R, and they have broken it down into 2 parts by defining another point in the middle called Q. So I can apply equations of motion from P to Q, Q to R, or all the way from P to R at once. So 3 options I have. I picked P to Q because then I have 3 information including U. And then the other one I took was from P to R, not Q to R. Is it clear to you why that is? If you write a list of information for the motion from Q to R, you don't have 3 information, you only have 2. So no point. Now, again, for P to R, I can apply S equals ut plus half at squared. Now, I will label this as 1. Because I have 2 unknowns there. I have U and A. Okay, I have U and A, 2 unknowns. That's why. I can relate the same 2 unknowns and get another equation out of this. So S is 1.6. ut 1.6 U plus A over 2 1.6 squared. That's my second one. Now, I will not do the, can you solve these 2 and find so in part 1, show that the deceleration is this and hence find U. So you have to necessarily find U and A. I will give you time to solve these 2 and find U and A. There. You can't count. So you are supposed to get, for A, I will just write the answers. For A, you have to get minus 2/3. And for you have to tell me. Okay, Malik is asking whether it is 23 upon 25. I don't know the answer, so let's wait and see. Okay, you know what? I'm going to do it quickly here. So the first equation, if I multiply everything by 2, and also by, let's see, 1.6 is equal to 1.2 u squared plus 0.36a. Sorry, what is u squared? No u squared, it's just u. That's the first equation. Second equation becomes, if I multiply everything by 2, 3.2 equals 3.2u plus 1.6 squared. What is 1.6 squared? Do you know what 1.6 squared is?
Miss 2.56.
You can use a calculator to solve this pair of simultaneous equations. You know that. Did anyone do that? Let me get my calculator. My papers are flying. So in mechanics, you don't have to waste time solving quadratic equations, solving simultaneous equations. If you get them into this form, the ax plus by equals, that form, you have everything in the right form, then you can use a calculator. Two unknowns, a1 1.2, b1 0.36, c1 1.6, a2 3.2, b2 2.56, c2 3.2.
Miss, when I solve it by the simultaneous equation way, I get a as minus 2/3, and I get for the initial speed, I get 1.53.
That's right. That's what I get too. And for y, you get minus 0.6 recurring. There you go. So you don't have to spend time. Do you all know how to do this using your calculator? You need to learn this. Do you know?
Yes.
Does everyone know how to do it? Okay, Malik knows. Girls, do you all know how to use a calculator okay, Hatfi knows. Please learn it. If you don't know, let me know. I will teach you how to do it. You just have to give these numbers. Coefficient of u, coefficient of a, and the constant on the other side. Coefficient of u, coefficient of a, and the constant on the other side in the two equations. And the cal will give you the two answers. Okay. So that's it for that. Is that clear? So you do not waste time doing the algebra. Okay. You are this is the mechanics paper. You are allowed to use the calculator to work this out. So we found this is same as a y. I'm sorry, not y, it's a. So I got for you, I get 1.53 means as a fraction. Is it 23/25? Ah, no, Malik, 23/25 is wrong. What is this as a fraction?
23/15. 23/15.
Correct. 23/15 meters per second. Those are your two answers. Okay.
Miss,
Yes.
should we write in fraction?
Better because that is exact now. It's not here. The dot notation is 3, 3, 3, 3, 3. I mean, when you put the dot notation, that is also exact form because you are saying 3 is repeating. But it's nicer to give it like that. Perfect answer here as a fraction. Okay. Then part 2. So this was part 1. Everything was part 1. Part 1. Part 2 is where you get your friction thing coming in. Let's read part 2. Given that the plane is inclined at 3 degrees, I'm going to draw this again because now I'm not going to be needing this PQR business or everything. They are just asking me to find the coefficient of friction. So this is to do with the forces. Okay. So this is a part where this is about F equals ma. The only thing I have to mark here is, so angle is given as 3 degrees. I highly recommend you to redraw because now it's a different diagram. Our focus is to something else. Earlier we were focusing on, see, did we draw the forces acting on them, on the particle? No. Did we mark the forces acting on the particle? No. That was not our focus. Here the focus was only to the features of the motion. USTA, all that. Okay. But now in part 2, this is about forces. So you redraw it, you need the angle, mark the forces acting on it. I will say that this is accelerating up. It's deceleration, it's a negative acceleration, but you have an A upwards, a negative A. And if I mark the forces, if you mark the forces, do we have the weight? We don't have the weight, so let me mark it as mg. Okay, we don't know the mass. I'm going to mark it as mg. Here's reaction R. What else would be there? Friction. Very good. Friction acting down because it's moving up. F max. Right? And immediately let me split or split the weight into two components, resolve the weight into two components. This angle would be 3. So mg cos 3 and mg sine 3. Okay. So I can ignore mg, this red force, the weight. Right. So I can consider vertical equilibrium. Yes, Mihir?
Miss, I have a problem, Miss. Now, how did you know that the friction is that showing downwards? Because Miss, they haven't mentioned that there is a force upwards.
No, no, there is no force acting upwards. They projected this up the. They project means you keep something on a slope and you give it a push, and it's now going up. It's moving up, Mihil. It's moving up.
Right.
It's going up.
Okay, Miss. Okay.
If it is going up, there is friction down. Okay.
Thank you, Miss.
Okay. So vertically, it's in equilibrium. So we can always apply vertical equilibrium even if this is moving. Li librium. Vertical equilibrium, if I consider, I can write R is equal to mg cos 3. Mg cos 3. Now remember, mass is not given. Then you can expect m to get cancelled. That's why they haven't given it. You don't need it. Okay. So you take it to be m and work with it. At some point, it will get cancelled. Vertical equilibrium, if when you consider forces this way, they are balanced. So R is equal to mg cos 3. Then this way, it's not in equilibrium. You can apply F equals ma. It's moving. It's accelerating. Okay. So this way, you apply F equals ma upwards. You apply it upwards because it's moving up. Right? Now, what is F? There are no forces in that direction. There are negative forces. That is why it's decelerating. You gave it a push and it started moving, and there are forces acting behind, like in the other direction. So you slow down. So there are two forces. You can add them. What are they? mg sine 3 plus F max. Plus F max. There are two forces acting down in the opposite direction. I'm applying F equals ma up. Very important. I'm applying it up. You apply it in the direction of motion. Equals m times, we have Ra minus 2/3.
Miss, then shouldn't F be minus? So it should be like minus mg sine 3 plus.
Oh, yes. Thank you, Malik. Both these are minus. That's a huge mistake. Both forces are negative. It's in the other direction. Minus mg sine 3 minus F max. Good. I can do mg sine 3. F max is mu r. So mu, I have mu is what I have to find. Mu r I have there. R is mg cos 3 equals m times minus 2/3. Do you see the m gets cancelled? You can divide the whole equation by m because m is not 0. Mass is a positive number. So you can divide the whole equation by m. And put g as 10. G is 10. Can you compute what mu is? Mu is what? Can you find it? Okay, Malik has 0.0144. I don't know, let's see. If I make mu the subject here, the minus sign also I can cancel off. I can divide by a minus sign. It's going to be 2/3 plus g sine 3, the whole thing divided by g cos 3. This is what you have to put into the calculator. Hatri says that is right. 0.0144. Can everyone make sure that you get that answer? Let me also check. Make sure you are in the degrees mode, your calculator. This 3 is in degrees. I got a different answer. Have I made a mistake? Oh, this is minus. This is minus. This is minus. 0.0144. Yeah. Zero point 0.01435. So it's 44 if you approximate it. Sorry, excuse me. Okay. Is that clear to everyone? What needs to be clear to you is not the way I did it. Is it clear to you why we applied the equations that we applied? Why wasn't it some other equation? Why did we apply vertical equilibrium? Why did we apply horizontally F equals ma? All those whys, why we did that, you have to understand that because you have to be able to do it on your own. It's not just like you are watching me doing it and then you go, yeah. Right? It's not that. You have to understand it so that you would be able to do it by yourselves too. So girls, again, I'm not hearing anything from you. I'm going to show you the next question. Oh, Tariq got disconnected apparently. Oh. So we just finished that question, Tariq. We found mu to be 0.0144. Because we are running out of time now, shall we look at number 3? Can you quickly copy number 3? I'm going to give you 4 and 5 for homework. Copy this question. Number 3. Can you quickly copy just 3 lines? So much of wind here. Isn't it, dear? Puta. He usually comes and says hi to the ayahs. Puta. Come, Puta, say hi to these ayahs and akkas. Akkala, ayyala. While they are, oh. Come, Chuti Puta, say hi. Miss, can you please? And yes, you can't see them, but they can see you. Okay. So let me see whether they can. If I change, say hi.
Hello.
So there is who said hello to you? That's Nathanaya. Nathanaya. Say it properly. Nathanaya. Yes, Nathanaya. Done copy? Mihal, you like?
Almost miss.
Oh, I'm sorry. I'm just reading your. He is so cute. Thank you, Joanne. And yeah, it's a sadhu cut, if you know what I mean. Like he just needs a robe now, and he will look like a little sadhu.
He has taken the crew cut, the ones which they
Crew cut, yeah.
have in the
Yes, yes, yes. Okay, are you done copying?
almost miss.
Okay. She doesn't give that cut to you anymore, Malin? What do you mean she used to give you that cut? No, that haircut suits some people.
I know, it's nice.
It's nice, yes. Think of all the huge celebrities who have this cut. Actors. Okay, are we ready to draw? Can I take the?
Almost. Hold on. Last bit.
Okay.
Is give me 10 seconds.
Three. Okay, Mihil is done. 4, 5.
Done.
Okay. Can I take the paper away, girls? Joanne. Okay. Right. Can you start drawing? So a block of mass. You start drawing, please. Number 3. Let's say a block of mass 5 kg is being pulled by a rope up a rough plane inclined. So it's always about an inclined plane. So here's my inclined plane. Draw big diagrams. Do we know the angle? Yes, 6 degrees. A block. So let me draw it like a block. Mass 5 kg. It's been pulled. And at some point they are saying it's moving at a constant speed. So I will put one arrow like that. Okay. And write like a V or just to say it's constant speed. It's not accelerating. It's moving at a constant speed. Okay. And let me start marking the forces acting on this. The weight downwards. Mass is 5, so the weight will be 50. Weight would be 50. Reaction force. R. Then it's being pulled by a rope up the rough plane. So you can mark a pull. This is like this could be the rope, and along the rope, what is that force? Oh, Hatfi is asking why I didn't put A, because it's not accelerating. It's moving at a constant speed. Put a tension. Okay, yeah, okay, you got it. Yeah, so this is tension, okay, because it could have been just a pull. Since they are saying it's been pulled using a rope, that would be a tension force. So you are pulling the rope is pulling the block. So along the rope, it's tension, okay? So this tension, do we know how much that is? No, so let's mark it as T. T, that force is T. What else we are going to have? Already we have three forces. So far we have 3 forces. What more? Friction. What direction? Nathan, what direction?
Friction is downwards.
Downwards. And is it the max or something else?
Max.
Max, it's moving. So F max. Okay. And before I do anything, let me resolve the weight. I'm resolving weight. Okay. This would be 6. This angle here would be 6. So this would be 50 cos 6. And this would be 50 sine 6. Okay. Now you can remove this 50 if you want. Right? So all your forces are in the vertical and horizontal directions. Okay. Now, coefficient of friction is given, mu is 0.3. Find the tension in the rope. Whatever they're asking us to find, again, what kind of a scenario is this? It's moving at a constant velocity. So it is in equilibrium. The forces are balanced both vertically and horizontally. So you consider vertical equilibrium and horizontal equilibrium and see what you can find. So, I mean, you don't even have to know what they have asked you to find. The only thing that you don't know is T, and you can find it. Okay. So you apply vertical equilibrium and then horizontal equilibrium. Why are we able to? It's moving, but it's moving at a constant speed. It is not accelerating. This comes from Newton's first law. We know that if an object is not moving or moving at a constant speed, the resultant is 0. We say that it is in equilibrium. Okay. So please make sure you understand that. So it's moving at a constant velocity. So we can consider, I will first consider vertical equilibrium. Consider vertical equilibrium. I get R is equal to 50 cos 6. I can find what that is, but let me keep it like that. I don't need it right now. Then I consider horizontal equilibrium. Horizontal equilibrium. If I show you the diagram again, T must balance 50 sine 6 and F max. Okay, so T is equal to 50 sine 6 plus F max. And in the next line, I can do T is equal to 50 sine x. Still, I'm not working it out. F max is mu r, mu is 0.3, I have up there, mu, and r is 50 cos 6. I can take it from here. R is 50 cos 6. 50 cos 6. Now I can simplify everything and find T. Tell me what you get for T.
Miss, is tension 20.1?
Yeah, Hatvi got the same answer. Good, 20.1 newtons. Good. How do you feel now about these questions? I'm just thinking there are 10 questions in this worksheet. We did only 3 questions. I want to do, so I said altogether, if we do 5 together, then I think you would be at a level where you can handle things on your own. So I'm not going to give you any homework. Maybe one, not a lot. So the 4th question I will send you for homework. Hatvi, wait, Hatvi, you don't get why we took? What is it? What we took R. What R? This is VV. Are you talking about this V that I wrote here? I wrote a V to say constant speed. If it is, if your object is accelerating, you would put 2 arrows and say A. I put just one line and one arrow. It looked like R for you. Okay. This was meant to mean constant velocity. Okay. So I will send you number 4 for homework. Just one question, 4 for homework. I would have liked it if we could do about 5 or together, but I will give you one to try. That 4th one to try for homework. Okay, so I will send you that right after the class. Any questions from what we did today? And then we will do one more class and do more questions on friction, and then we will start connected particles. This comes under forces and motion. Okay. And also there is another little thing that we have to cover in friction that also we have to do. Okay, so we'll do that next week. Any questions?